Okay, we'll look at some of the homework problems in section 5.1, which deals with the integers and the operations of addition and subtraction. We'll first find the opposite, or what they call the additive inverse of negative 62. Okay, so here, in this case here, we drop off the negative sign here, and it'll end up being positive 62. So the opposite of negative 62 is just plain 62. Or you can say the additive inverse. You can think of the number and its additive inverse will give you 0. So negative 62 plus 62 will give you 0. So 62 is the opposite of negative 62. Alright, the second one is to evaluate. This one is the absolute value of 34. Of course, absolute value is the distance. The number is from 0 on the number line. So 34 is 34 places to the right of 0. So the absolute value of 34 is simply 34. Okay, let's look at the next problem. Here we're going to subtract by changing subtraction to addition. Okay, so if you recall, anytime you subtract integers, that's the same as adding the opposite of the second number. In this case, 8 minus negative 6. Negative 8 minus negative 6. In this situation here, we're subtracting negative 6. And that's the same, when we subtract a negative 6, that's the same as adding the opposite of negative 6, which is simply 6. So now you got negative 8 plus 6. And then negative 8 plus 6, of course, if we have different signs and we're adding, we're going to take the sign of the larger number, which is negative, and subtract, or the larger absolute value, and then subtract. So here, negative 8 plus 6 would give us negative 2 as our answer. All right, number 4, write an addition fact that corresponds to the following sentence, and then answer the question. Here it is. On 3 consecutive passes, the football team gains 8 yards, loses 11 yards, and gains 33 yards. What number represents the total net yardage? Okay, so here we want to write an addition fact that corresponds to that sentence. The football team gains 8 yards, so that means that's going to be a positive 8. Plus, now they lose 11 yards, so losing 11 yards will be negative 11. And gains 33 yards will be positive 33. So this is the addition fact that corresponds to the given sentence. 8 plus negative 11 plus 33. Now we want the total net yardage. To simplify this, let's add the positive numbers together. 8 plus 33. That's 41. Plus negative 11. And then we're adding a positive and a negative, so that means we're going to take the sign of the larger absolute value. 41 is the larger of the two, and it's going to be positive, so let's subtract 11 from 41. That's going to give you 30. Okay, so the total net yardage in this case will be 30 yards. Okay, next problem. On January 1st, Jane's bank balance was $450. During the month, she wrote checks for $40, $55, $175, $30, and $100, and made deposits of $65, $25, and $300. Now in part A, if a check is represented by a negative number and a deposit by a positive integer, express Jane's transactions as a sum of positive and negative integers. That's part A. And then part B, what was the balance in Jane's account at the end of the month? Okay, so in this case here, okay, we're just going to express her transactions here. She wrote checks for $40, $50, $175, $30, and $100. So those will be negative numbers here. So we'll say this is negative 40 plus negative 55 plus negative 175 plus negative 30 plus negative 100. And then $65, $25, and $300 are her deposits. So those are positive numbers. 65, 25, plus 300. Okay. All of this represents the sum of Jane's transactions. That's part A, as they just want a algebraic expression expressed as a sum. Okay, so you're not to simplify. Now in part B, what was the balance in Jane's account at the end of the month? Okay, so now we got this to deal with. Her bank balance was $450 plus, I'm going to add all the negatives, which is all the checks. 40 plus 55, that's 95. 95 plus 175 is negative 270. Negative 270 plus 30 is 300. Negative 300 plus negative 100 is negative $400. And then we're going to add all the deposits. 65 plus 25 is 90 plus 300 is $390. Okay, and then we can add this sum together. 450 plus negative 400. The signs are different, so we subtract and take the sign of the larger. 400 from 450 is 50. 450 is the larger of the two absolute values, and it's positive. So 50, you have positive 50, then plus the 390, which will give you 440. So Jane's balance at the end of the month is going to be $440. Okay, next problem. Let's say we have this one. Negative 6 plus 2 minus 5. Now here we're going to do order of operations here. In this particular situation, we start from left to right. Negative 6 plus 2. The signs are different, so we subtract and take the sign of the larger absolute value. So negative 6 plus 2 will equal negative 4. And then you got negative 4 minus 5. Well, negative 4 minus 5 is the same as, say, negative 4 plus negative 5, which is negative 9. Because when you subtract, that's the same as adding the opposite. So in this case here, negative 6 plus 2 minus 5 will give you negative 9 as the final answer. Okay, the next problem reads, you want to write a subtraction problem that corresponds to the question and an addition problem that corresponds to the question, and then answer the question. The temperature is 82 degrees Fahrenheit and is supposed to drop 29 degrees Fahrenheit by midnight. What is the expected midnight temperature? So here we want to write a subtraction problem. 82 degrees Fahrenheit, and we're going to drop, and it's going to drop 29 degrees Fahrenheit by midnight. So in this case, that subtraction problem will be 89 minus 29. Okay, that's your subtraction problem. The addition problem that's related to this, well, the addition problem is this. You're subtracting a positive 29. That's the same as adding to 89 the opposite of 29, which is negative 29. So now you get negative 89 plus negative 29. And then the expected midnight temperature, pretty much if you subtract and take the sign of the larger absolute value, you're going to end up getting 60. So the expected midnight temperature will be 60 degrees Fahrenheit. Okay, let's look at the next problem. Here we got negative 6 minus, and in parentheses, 6 minus 4x. And we want to simplify this expression. Okay, now the way that this can be done is this. I'm going to bring over the negative 6. This minus sign is going to change the sign of each and every term inside the parentheses to the opposite. This is like using a distributive property. That means this negative sign will make the plus 6 a minus 6. This negative sign would make minus 4x a plus 4x. And then we're going to simplify this. Negative 6 minus 6, or think of this as negative 6 plus negative 6. That's negative 12. Then bring over plus 4x. Now you can leave this as negative 12 plus 4x, or you can write this as 4x minus 12. Either way, these two expressions are the correct way of simplifying your answer. All right, number 9. Given the function f described by f of x is equal to negative x minus 8, find f of negative 9. Okay, so here we're evaluating f of negative 9 using this expression. We replace the x with negative 9, so here we're going to have this negative sign that's in front of the x, but then we replace that x with negative 9. So we got negative of a negative 9 minus 8. In this case, the opposite of negative 9 is 9. So it'll be 9 minus 8, which will equal to 1. Okay. This means f of negative 9, meaning you want to evaluate this particular function at x is equal to negative 9. So we're replacing the x with negative 9 to get this expression right here. Here we have to bring over this negative that's in front of the x as part of the expression. The x has already been replaced with negative 9. So the opposite of negative 9 would be 9. 9 minus 8 is 1. All right, next problem. We're going to let y equal the absolute value of 4 minus x. And you want to find the value of y for each of the following values of x. And this is part A. When x is 10, we want to find out what y is equal to. Okay, so in this case here, 4 minus, and then x is 10, so we replace the x with 10. So we have the absolute value of 4 minus 10. We need to simplify what's inside the absolute value symbols here. So 4 minus 10 is negative 6. So you have the absolute value of negative 6. Now, when we take the absolute value of negative 6, it's going to be positive 6. Keep in mind, the absolute value is always going to be positive. It's never going to be negative. All right, part B, when x is equal to negative 9, we want to find out what y is. So here y is equal to the absolute value of 4 minus, and then x is equal to negative 9, so we replace the x with negative 9. Okay, so now you got 4 minus negative 9 inside the absolute value symbol. Well, 4 minus a negative 9 is the same as 4 plus 9. That's 13. So now you have the absolute value of 13, which is simply going to be 13. Again, the absolute value is always going to be positive. It will never be negative. Okay, part C. We want to find all the values of x for which y is equal to 1. In other words, we want to find out all the values of x, where the absolute value of 4 minus x is equal to y, which is going to be 1, because y is going to be equal to 1, so we replace the y with the 1. So here you have absolute value of 4 minus x is equal to 1. Now, if you recall back in algebra, when you were solving absolute value equations, you had to rewrite this as two separate equations. The first equation means this: 4 minus x is equal to positive 1, or the second equation would be 4 minus x equals to negative 1. Okay? Because that's the format of writing an absolute value equation. The expression inside the absolute value would be equal to the positive constant. The second equation will be the expression inside the absolute value symbol equaling to the negative, or the opposite of that constant. Then you have two equations, each will solve for x. So let's say if we subtract 4 on both sides. That means that negative x is equal to negative 3. And that would mean that x will have to be equal to the opposite of negative 3, which is 3. Or, if we subtract 4 on both sides in this equation, for 4 minus x equals negative 1, that means negative x is equal to negative 5. And then x will be the opposite of negative 5, which is 5. So all the values of x for which y is going to be equal to 1 would be these two numbers, 3 and 5. Okay, so here this is how you will solve an absolute value equation. Okay, number 11. Determine the common difference in the next two terms of the arithmetic sequence. We got negative 1, negative 5, negative 9, negative 13. Well, let's look at the common difference here. From negative 1 to negative 5, we are adding negative 4. And we're adding negative 4 to negative 5 to get the negative 9. Add another negative 4 to the negative 9, you'll get negative 13. So the common difference here is negative 4. So now we want the next two terms. So to do that, we're going to have to add negative 4 to the negative 13. That would give us negative 17. Now we add negative 4 to that negative 17 to get the next term. That's negative 21. So these are the next two terms of that arithmetic sequence, negative 17 and negative 21. And of course the common difference is 4. And finally, number 12, we want to solve the equation and check the solution. Negative 7 plus x is equal to 7. And what I'll do here is write this. Negative 7 plus x is equal to 7. We want to get x by itself, but we got negative 7. What's the opposite of negative 7? It'll be positive 7. So let's add 7 on both sides of the equation, because we want to get the x by itself. So if I add 7 to the left side, I also need to add 7 to the right side, because I've already got the negative 7. So that's going to cancel, leaving me with x equal to 7 plus 7, which is 14. Now to do the check, we take x equals 14, we replace the x with 14 in the original equation. So now we got negative 7 plus alright, and then x is going to be 14, so that's going to be negative 7 plus 14. That should equal 7. And if you add negative 7 to 14, you do get 7. So that checks. So that means x equals 14 is the solution to that equation. And this should be enough to assist you with the homework problems in section 5.1.